We will start today on module 2, which is about roundabouts. Roundabouts, okay. We will study in the roundabouts the geometric design assessment, the capacity analysis, and how to determine the level of service for a roundabout. Roundabout, we'll start with the first part, which is the roundabout design, geometric design safety assessment. Okay. Basics, before we start on roundabouts, let's have just a quick review and the basics of roundabouts. Let's get, to have a historical background. What you see here, this is Columbus Circle in New York City, okay, in 1920s. So we have roundabouts since old, that's almost 100 years and maybe more in some locations. So it's basically a circular intersection island, okay? That was the early inception of the roundabouts. This is another roundabout, okay? Also but this one is in Cairo, 1930, okay? It connects between I think between 6 roads intersecting together at one point. To have a background, okay, roundabouts, it's an old style circular intersection. Okay, it was common in the United States before the 1960s, and there was rotaries also. You can read this later on. In this slide, you see this is a traffic circle. That's a small diameter for low-speed urban areas. Okay, that was in the 50s, something like that. However, it started evolving, okay, and in the 50s, they came up with this alternative for intersecting highways. So it was a large circle. It was called traffic rotaries or traffic circle, okay? Instead of building interchanges, they used to do this on freeways and on highway, okay? That's for high speed. That's why you see, the large diameter that we have here. This allows, you see, just to give you an order of scale, that's a truck. So you can compare this diameter to that size.
صوت قطع يا دكتور.
Yes, I noticed that.
Go to the show.
Okay, hold a second. Let me just shut down some applications that might be causing this issue. Okay. So what I was saying is that, if you look at the size of this truck, compare it to that diameter, you will get, a feel for that distance. However, that same roundabout, okay, they started to modifying it to be on that scale. I think this is an, artificial. Oh no, that's correct. So back again, that was the roundabout, the Columbus Circus in 1920, and here in 2012, and how it evolved. You can see that the small circle here, the diameter increased significantly. Okay, there was a control, there is pedestrian crossing all over the place. There is lane channelizations. Here it was, this is a electric tram, okay? And you can see here that it was divided into, here it was, there was no lane divisions and stuff like that. Here, that's the optimum roundabout that we look for. So, the modern roundabout, what are the benefits of modern roundabouts? Okay, first of all, safety. The physical shape of the roundabouts eliminate the crossing conflicts that are present at conventional intersection. Remember yesterday's lecture when we were talking about the left turn, okay? And there is a crossing point. In roundabout, this conflict point does not exist. Operational performance, okay? Roundabout typically have lower overall delay. You don't have to wait in a queue for the green light, okay? So, and even it's better than all-way stop controlled intersection. Okay. Roundabout benefits also environmental factors. By reducing the vehicle delay, you are reducing emissions. Also, access management. Okay, it reduce or eliminate left turn movements at driveways between major intersections. That's one of the advantages. Another advantage is traffic calming. Okay, traffic calming basically roundabouts force the traffic to slow speed, so that's another advantage. Also, pedestrian safety. In roundabouts, there is a very strict treatment for pedestrian safety. If you look here in this at this model roundabout, okay, you will see that there's pedestrian crossing for each approach here and here. Here, this is something to prevent pedestrians from entering the roundabout. So there is another pedestrian crossing. There is island here for pedestrians. There is yield, so traffic stop here, slow down. People can cross here easily. So it's for pedestrians, it's much better than uh, uh, traffic signal. Aesthetics, that's from, roundabouts looks beautiful. You can put a water fountain in the middle. You can put some flowers, something. Okay, they look good. Land use. Okay, roundabouts can provide a transition area between high-speed rural area, and it's good in this kind of transition. Also, the ongoing operation and maintenance. Okay. For traffic signals, you have to go and check the electricity, check the controller, check the light bulbs for the signal to make sure that the connections are correct and working. But the roundabout doesn't need any of this. Approach roadway width. Roundabout may reduce the amount of widening needed on approach roadways in comparison to alternatives. Sometimes in congested intersections, we have to add lanes, okay, to increase the capacity of the approach. But here, you don't need to do that. Okay, here we will go through a comparison between roundabouts versus traffic signals. As you can see, the first point, conflict points for vehicles. These are the conflict points for a signalized intersection. These are the conflict points for roundabouts. You count it here. We have here 16 crossing points. We have 8 diverging points, 8 converging points. Here we have 0 crossing because all turns are converted into right turn. We have divergence, 4 diverging points, 4 converging points. So the number of conflict points reduced significantly. Here we have total of 8. Here we have total of how much? 32. So here, 1/4. And the big advantage, we have 0 crossing. These are the most dangerous points, conflict points. For pedestrian safety, as you can see, we have here 16 crossing, and here we have 8 crossing points. You see the difference? The third criteria, crash types. and that's very important. The crash types,
دكتور
yes,
ممكن نرجع لسلايد 74.
yes.
فوق يس دكتور، كيف 16 كروسنج اللي على اليمين وفي النص هم؟
You see these points in blue? Count these points. These are 16 points. Okay? Clear?
اوكي تمام، يعني في 16 تقاطع بين الاربع الشوارع هذه او اربع.
No, 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 no. What we are talking about here is basically that there's crossing points between different vehicle movements. Okay, let me just explain it to you in a better way. Okay,
يعني تقاطع السيارات، حركة
hold a second.
السيارات، حركة السير.
Hold a second. That's a movement. Okay, that's a movement. And that's a movement. From the other approach, we have another movement this way. This is what we mean with crossing point. There is a movement going this way. That's a crossing point. And that's another crossing point. And that's another crossing point. And so on. Is that clear now?
So the total is 16. Yes.
Yes, when you do this for all movements, you end up with these, blue dots, light blue dots. These are 16 points. Clear?
Yes.
Okay,
Thank you.
you're welcome. So the crash types. For roundabouts, most of the accidents are side sweeps. Side sweeps, that means a car coming from this direction, car from this direction. They are not, they are at smaller angle. But here for intersections, either angle, that one, a vehicle going in that direction, a vehicle going that direction, okay, that's 90 degrees, or front end collision, like this one. This car coming this way, this car coming this way, and there's a crash. Both crashes are the most dangerous, and the consequences of these crashes are usually fatal. So even the accidents in roundabouts, let me just correct this, in the correctly designed roundabouts, okay, are side sweep like what we have here. The other or the last point is that the cost of operation and maintenance. Roundabout doesn't need any, there's no cost associated. So we don't have signal equipments to install, to power, and to maintain, and may require less right of way even, less pavement may be needed at roundabouts. Other advantages for roundabouts, aesthetics. As you can see, we can put some plantations in the roundabouts. We can have some palm trees, as you can see in the picture here, and so on. It's quieter. It's functional. Okay. Let's now go to the roundabout capacity. Just to give you a basic, roundabout capacity, a basic question that needs to be answered at planning level: how many entering and circulating lanes? Actually, we're going to shift this one to that when we start talking about capacity and analysis for level of service. Okay, roundabout geometric design safety assessment. So now we just have a brief introduction to roundabouts and the benefits of roundabouts. Let's now go to how to conduct a geometric design safety, assessment for roundabouts. Before we start, we need to understand what are the geometric elements for a roundabout. Okay, modern roundabout has the following distinguishing characteristics. It needs to have channelized approaches, yield control at all entrances, counterclockwise circulation of all vehicles around the central island, and appropriate geometric curvature to encourage slow travel speeds through the intersection. As we can see here, okay, all entries must have a yield line or the stop. That's an entry points. As you can see here, that's an entry point. The entry point must be defined, okay? And there's usually yield. Yield means that you give the right of way to the opposing traffic, okay? It's similar to what we have here when we have this sign that say الأولوية لمن بداخل الدوار, okay? But unfortunately, for most of our roundabouts, I don't see these entry lines. So you cannot define where is the beginning of the roundabout. Okay. There's the inner circle. Okay. And there's the flow and the circulation area. And there is channelization. Each lane of these, it has specific movements allowed. Okay, as you can see, this one, for example, this lane is for through and vehicles that are turning left. So that means a vehicle from here can go this way or continue this way. Okay, and so on. And also there is the entry. This is what we call splitter island, and it has a curvature that forces drivers to slow their speed while entering to the roundabout. Okay, so the items or the geometric items, first of all, the diameter of the roundabout, it's measured from the outside to the outside, or from here to here. It's not measured on the island or the inner island, no. So we have the central island. We don't, it has a roundabout, but it's not the criteria. We have here what we call the inscribed circular diameter, okay, of the roundabout. This area, it's called the track apron. These are at the same level as the pavement, but it's made from another material to allow trucks, okay, to turn on the roundabout. And there is an entry, there's an exit. As I mentioned, there must be an entrance line, as here, okay? And there is a circulatory roadway, okay? It can be 1 lane, 2 lane, 3 lanes. It should be defined. And as I mentioned, these are the splitter island. It needs to have a curvature reasonable to slow down the traffic. And we will discuss how to identify or define that curvature. So here are the description of design features and the function for each one. The central island, okay? It's basically the island inside it's a central island, it's raised area, okay? And it's around which traffic circulates. That's where the traffic will circulate around. The splitter island, this is very important. The splitter island, its main function to separate entering from exiting traffic and to deflect and slow entering traffic, provide storage space for pedestrians crossing. And it's very important to understand this, the function of the splitter island. I will give you an example quickly. If you can just hold on with me for a while. I will show you an example. Hold on with me for a while, just for a second. Okay, watch this. What is this? Okay, this is a car crash in a roundabout in Poland. Okay, they just took off. So what was the reason for this? Look carefully at the splitter island. The splitter island,
يمكن شكل السبليتر ايلاند.
the splitter island doesn't have the geometry,
تفضل.
okay, to force the driver to slow down. You see my point? There was someone making a comment.
اقول شكل السبليتر ايلاند يعني ما كان مايل بحيث انه يوضح لنا الطريق.
Exactly. I will show you another thing also here. I will walk you through that roundabout. That's the exact location of that roundabout. And that was the street that the vehicle came from. Okay, that's the same view. Okay, if you keep going, we're using the street view from Google. Okay, that's a splitter island. It has zero deflection. You get the point? Okay, so most probably that driver, he was not from that area. He is not familiar with that interchange. So he just came and just had this unfortunate accident. So let's go back to our notes. So here it must deflect and slow entering traffic, okay, and provide storage space for pedestrian crossing. Let's go back to that one. Yes, it provides storage space for pedestrians for crossing. So those pedestrians that you can see in the picture, okay, are crossing. They're gonna wait here until they have a acceptable gap. Then they can, continue cross. As you can see, there is, handrail to prevent pedestrians from entering the roundabout. That's a good feature. You can see the handrail here, but they just forgot to slow the traffic down. Okay, so let's continue. The circular, so we mentioned that we have the design features. We have the central island, okay, and the splitter island. And also there is the circulatory roadway. The circulatory roadway, that's basically the area that the vehicles drive through. That's the circulatory roadway. Actually, the number of lanes here will depend on the entering number of lanes. And usually we try to keep it within 3 lanes. More than 3 lanes, things becomes messy. Apron, as I mentioned, apron, it's basically to accommodate the wheel tracking of large vehicles for trucks and so on. Yield line, to mark the point of entry from an approach. As I mentioned, there should be a line for the vehicle to mark, that's the beginning of the roundabout.
صوتي قطع دكتور.
Okay, so which part you didn't listen to?
دكتور صوتك يقطع. صوتي يقطع دكتور. دكتور الصوت يقطع.
Okay, hold a second. Now we still have the same problem? Can you hear me clearly? Okay. So what I'm saying is that we have the apron. The function of the apron is to accommodate the wheel tracking of large vehicles. There's a yield line, the yield line to mark the point of entry from an approach onto the circulatory road. Assalamu alaikum. Assalamu alaikum.
والسلام.
Can you hear me?
الآن
يس
أوكي.
دكتور.
ايوه واضح.
اوكي.
ايوه نسمعك يا دكتور.
طب كويس، الحمد لله. طيب نبتدي نرجع نعيد من اول فين؟ من اول الابرون. Okay. The function of the apron basically is to accommodate the wheel tracking of large vehicles. The yield line to mark.
ترى ما قطع الصوت من بعد ما رديت عليك وعادها ما كنا نسمع شيء.
Okay. Can you hear me now?
الحين ايوه.
طب كويس. Okay. The apron, okay. The function of the apron is to accommodate the wheel tracks for large vehicles and trucks. The yield line to mark the point of entry from an approach into the circulatory roadway or to the interchange, the roundabout. And the accessibility to pedestrian crossing. Accessible, it should be, there should be a pedestrian crossing, okay? Accessible pedestrian crossings should be provided at all roundabouts, okay? And also there should be prevented from entering the roundabouts from other points than the access points. For example, here, there's a very critical part, which is this part. Okay. This part is basically, it's meant, okay, landscape buffer. This area.
Doctor, can you please repeat what you just said?
Okay, this area is a landscape buffer. Okay, the function of this area is to prevent pedestrians walking on that sidewalk from entering the roundabout from here. So pedestrians are limited to these points, to the pedestrian crossing. They cannot, enter.
صوتي يقطع دكتور.
Okay. Pedestrians cannot enter from any point.
دكتور أنت سلايد 88.
Yes.
السلايد الآن يا دكتور أنت في سلايد 88.
يس.
إيه اوكي، عشان نحسب الصورة معلقة ولا.
ما انت شايفني بكتب عليها يا ابني.
لا انا نفس الصورة معلقة، ما تغير شيء.
ازاي يعني انت مش شايف في كتابه هنا؟
ايه الحين في كتابة.
طب
توها
مش في
تغيرت،
مش في كتابه
توها الان
موجوده قبل كده؟
تغيرت، ما في شيء الان.
يعني المنطقه اللي انا بعمل فيها دي كده في كتابه فيها عندك فيها هنا؟
الان ما في يا دكتور، قبل شوي الخط اللي كتبته بالاحمر موجود، شفناه. تو صار داير على الكلام. وش إيه؟
لا سؤال يعني، خليك بس معايا دي واحده كده. كده في حاجات مكتوبه على الشاشه ولا مفيش حاجه مكتوبه؟ في حاجات باليد مكتوبه؟
لا ما ايه موجودة. يمكن هو قصده انه كتب الان يبغاك تشوفه.
لا انا
ما
ما بكتبش
مكتوب،
الان، في
بس
حاجات
من اول
مكتوبه
مكتوب.
بالاسود وفي حاجات مكتوبه بالاحمر. تمام، موجوده الحاجات الموجوده بالاحمر شايفها؟
ايوه الدوائر محدد على الكلام.
دي في الاول كنت شايفها برضو ولا ما كنت شايفها؟
ايوه كانت موجوده من الاول، بس الكلام اللي كتبته في النهايه ما شفته، تونا شفناه الان.
انا ما كتبتش كلام. فين الكلام اللي كتبته؟
يقصد التحديد اللي على اللاند، التحديد اللي كتبته على اليمين، لاند سكيب بفر.
ماشي اللي على اليمين ده، لكن ده وانا كنت قبل ما توقفني كان الحاجات اللي انا بشاور عليها دي والبيدستريان كروسنج، الحاجات دي كنت شايفها ولا لا؟ يا شباب
دكتور ما نسمع صوتك ابدا.
دكتور والله ما سمعنا صوتك يا دكتور.
طب
قطع
خلينا
تماما
نغير
يعني.
المايك اصلا.
دكتور هو انت تكتب صح، بس انه احنا ما تجينا الا متاخر.
طب ماشي انا هعمل حاجه دلوقتي. اوكي كده سامعني؟ كده سامعني يا باشمهندس؟
يا دكتور احنا
شباب
دكتور
إيه
احنا
كذا
نسمع
سامعينك.
صوتك بس في تقطيع يا دكتور بعض الاحيان، يعني تقول
لا ما
جمله
انا
في النص
غيرت
يقطع.
المايك اصلا،
ايه
لان المايك كان شابك على الكاميرا، فلغيت الكاميرا بالمايك خالص. تمام، وبشتغل من المايك بتاع الكمبيوتر نفسه. هتلاقي حتى الصوت الدقة بتاعته مش عالية كده. يعني هل في دلوقتي تقطيع في الكلام ولا الدنيا
لا
ماشية
دكتور
كويس؟
نفس المشكله موجوده، مقطع كثير.
طب خليكم معايا بس، هعمل حاجة على الراوتر واجي لكم دلوقتي. طيب يا شباب، الصوت كده اوضح ولا في ايه، ولا في مشكلة برضو؟
اوكي واضح الصوت الان.
طب كده اتحسن افضل
الان
ولا في
الصوت
تقطيع؟
واضح.
ممتاز يا دكتور.
واضح وفي تقطيع ولا مفيش تقطيع؟
الى الان ما في شيء.
طيب نكمل تاني بقى. What we were talking about regarding the accessibility for pedestrians. Okay, so pedestrians, they have pedestrian crossing that are accessible to all pedestrians. Also, there is points that are meant, as I mentioned before, here to prevent pedestrians from crossing or from entering the interchange, or from entering the roundabout. They are limited only to these crossings. They can cross from here or from here or from here. If you remember what we showed on the previous video for the interchange you can see that image. Hold a second. Here, they don't have plantation, but they have this handrail. You see this? شباب
Yes.
شايفين الهاندريل الموجود هنا ده؟ الوظيفة بتاعته ان هو يمنع البيدسترينز من ان هم يدخلوا الراوند اباوت من اي نقطة. تمام؟ طيب النقطة الثانية البايسكل تريتمنت، المعالجة للبايسكلز. بالنسبة للبايسكلز اوكي الراونداباوت it provided treatment للبايسكلز بحيث so they can be use the main road or they can either behave like vehicles or as a pedestrians. Okay, and also there is a landscaping buffer, as I mentioned before. The landscaping buffer is to separate vehicles and pedestrian traffic. Okay, so that's one of the main features for modern roundabout. Now, the key dimensions or the key design dimensions for roundabout, there is what we call the entry radius, this area. This entry radius, okay, it determines the speed of entering the roundabout, okay? And there is the circulatory roadway width, okay? And there is the exit width. There's the inscribed diameter, okay? And there's the exit radius. The exit radius determines the exiting speed. Sorry. The exiting speed is determined by the exit radius. The entry radius determines or dictates the speed of entry. Okay, so for that accident that I showed in Poland, there was no entry radius. The road was just straight to the roundabout, and that's very dangerous. Okay, the key design dimensions are the inscribed circular diameter. This is basically determined or designated by the volume, okay, and the needed speed on that roundabout. The circulatory roadway width, which is basically the number of lanes, and this depends also on the diameter of the roundabout and the approach width and the departure width. These are the key design dimensions. Here is a recommended design, for the inscribed diameter, okay, based on the design element. For example, here the design element, the desirable maximum entry design speed. If we're talking about mini roundabout that's in a neighborhood or in a small urban area, it's between 25 to 30 kilometers per hour. For a single lane roundabouts, the entry speed should be between 30 to 40. For multi-lane roundabout, okay, it should be between 40 and 50. So the geometry, okay, should not allow more than this. If it allows more than this, that means it's exposing drivers in the roundabout to hazards. And the maximum number of entering lanes per approach for mini roundabouts is just one lane. For single lane, it should be one lane roundabout. For multi-lane, it's 2+, okay? The typical inscribed circular diameter for mini roundabout, it's 13 to 27, and it could be fully traversable. Traversable, that means it's not raised, just painting on the pavement. But for a single lane roundabout, it's between 27 to 55 meters. That's the maximum. And it should be raised. Okay. For the multi-lane roundabout, it's between 46, the inscribed diameter, from 46 to 91 meters, and should be raised. Okay. With apron. Yani for all of this, it's recommended to have apron. Okay, the apron allows for heavy vehicles to traverse, if they are using it. So, what is the typical daily service volume? Okay, for a four-legged roundabout, if it's up to 15,000 vehicles per day, we use the mini roundabout. Up to 25,000 vehicles per day, we use the single lane roundabout. But for more than this, for 45,000, up to 45,000, okay, vehicle per day, for a two-lane roundabout, we use the multi-lane roundabout. And actually, these volumes are the total volume on the approaches. That means that's the volume from this approach, volume from this approach, from this approach. Or the sum of these volumes, okay, should be, up to 45,000 vehicles per day. Any questions? Okay. What are the objectives of design when we are making this design? Basically, the first objective is to provide slow entry speed and consistent speed through the roundabout by using deflection. Okay, so the primary objective is not just to have a roundabout and entry. No, we have to slow down the speed. So there should be a curvature sufficient to slow down the speed of the traffic flow. I'm gonna stop here and we are gonna continue next week, inshallah. But before we stop, I need to take the attendance. It seems that we have 2 students are absent.